Hello everyone, here is the sprinkler system, the hardware device, and you will notice that the ESP8266 is not connected to my laptop. The USB is just open. Now I'll turn on the power for this so we can see what happens. So it's saying connecting to ChandraNet1, which is my Wi-Fi, and then now it has booted, and you've seen the time change from 00 to 1741, which is the current time now. So that means the NTP has worked and the board synced itself to the current time. Now here I'll show you how to flash the board with new software. So the device that I'm going to flash is Sprinkler Terrace, so you can name each device something different. And then I'm going to run this target upload, and I'll do a target of OTA, so which is basically over the air update. So when I try to flash the device, it uploads this software, new software, over the air without needing the USB cable. So you can see the progress both on the device as well as on my laptop. And once this is done, the board will reboot and the new software will start running. You can see the blinking LED at the bottom, which indicates that the board is flashing. Right now the board is trying to reboot, so light is off, and the solid light indicates it's trying to connect to the network, and a blinking light like that indicates that everything is ready and you can start using the board. Now let's take a look at the software. So I quickly want to go over the software for the drip irrigation system. The first file we are going to look at is this constants.h file. This is where all the constants are stored. So in my case, the Wi-Fi SSID, the password, which I've X'd out here, but normally you'd have the right password there. Then the OTA host name, which is the same as host name. So right now the host name I've set it to sprinkler right, but when I actually flash it to the device, this will keep changing based on what I provided the command line. So on the command line I can change the host names to different things, so I can flash to different devices. So then we have the WebSocket port and the web server port, which is normally 80. So these are the pins that I've used on the ESP8266. So the LCD pins, and then the sprinkler pin, which is connected to D1 on the board. So when I make D1 high, the sprinkler will turn on. So the main program starts here, and as you can see, there's some basic setup of the serial port, then LEDs and LCD setup. There's already an inbuilt LED on ESP8266, which you can use to show status. So I've used that to show different blinking statuses to indicate failure or success. So for example, if it blinks 300, then setup has failed. So if the LED is on for 10 milliseconds and off for a second, then everything is working fine and it's ready. So after setting up LCD and LED, I set up the OTA, which allows me to flash this device over the air. So I don't have to connect a USB cable to the device from my laptop to flash it. I can just flash it over the internet. Then I connect to the internet, my Wi-Fi. And I also set up MDNS so that I can look up the device without having to know the IP address. So I have the host names such as sprinkler right. So if I search for sprinklerright.local on my browser, it should be able to find the device. So that way I don't need to remember the IP addresses. And after that, so after setting up Wi-Fi and MDNS, I set up the home automation. The sprinkler automation, and this one actually controls the sprinkler based on a given schedule or based on commands coming from the WebSocket. So somebody can control the sprinkler from a browser. So next I just loop. So if you know Arduino programming, there is a setup section and then there's a loop section. So in the loop, this continuously tries to handle any OTA requests updating the LED based on the status, and updating MDNS and the sprinkler. So LCD code is quite simple. I just extend the liquid crystal library and add a few functions to simplify things. Like if I want to show a message in 2 lines of the LCD display, there are 2 lines, so in show line 1 and line 2, and then just calling into the library's print statements. Then LED is simply to turn on and off the LED light. So elsewhere in the code I could just call this blink method, and I can tell how many milliseconds the light should be on and off, and every time the update is called, it will check if the light should be on or off, and based on that the LED blinks. Then there is the Wi-Fi, the usual stuff. Just connect to the Wi-Fi, and if it's not connected, wait for a second and still keep checking like that until it's connected. So this is a blocking function. So initially if the Wi-Fi is not connected, then the device will just get stuck there, but hopefully the Wi-Fi is there and it can connect. Next is MDNS. So this is the, as I said, like this is where I set up a name for the device. So we try to give it a name and see if MDNS was successful. If not, then there is an error. That way we can show a blinking LED which indicates error. If everything is fine, then we just print the host name on the serial port and continue. Next we go to the Ntp code. So this is the one that sets up the time, date and time on the device. So while the device has a real-time clock, it does not store the current time. I mean, every time you turn off the device, that information is lost because there is no battery backup. So I used Ntp to fetch the latest time from Ntp service. Now that we have Wi-Fi and hopefully there is internet, so we can just fetch the current time and then save it on the device. And then this is the over-the-air updating code. So just the host name and any password that you want. And when a client connects to it, I change the blink to 300 milliseconds on and off, and I display that OTA update has started both on the serial port and on the LCD display. And on end, OTA has ended, it's not busy anymore, and we can restart the device at this point. So, and then the new code that was flashed onto the device will start running. And there is some on progress method to just show what is the progress status. No need to go into all these details, but basically it shows the progress indicator on the LCD and also on the serial port. And on error, some error messages. Next we have the web server running. So the web server will actually serve all the files from the SPI file system. There is already a library called the ESP async web server, which asynchronously handles client requests, and any request for / will go to index.html, and all of the files will be statically served through whatever is there on the file system of the device, and you just basically start the server here. So next we have the automation part, and what basically happens here is it just sets up the Ntp web server and web sockets and everything, and whenever a client connects and gives it a command, for example to turn on the sprinkler or something, it will handle the messages like this from on message from client, and then it will turn on the sprinkler or send the schedule to the clients or save the schedules, update the schedules. All of that is handled here. And a schedule is nothing but the hours and minutes of when the drip irrigation should start, and the duration for how long it should be turned on for. And sprinkler is the code which will turn on and off the drip irrigation by setting the pin high. So if you turn on, then it will turn on for duration in seconds. So whatever the duration is for that long, the pin will be set to high, and after the duration is over, the pin will be set to low, and then the drips will stop. So that's pretty much it for the code. I'll just go with the build script. So this is a like really short build script I have. So these are all the usual stuff that you have. The platform ESP8266 and board is Node MCU type. Monitor speed and everything. So here is the interesting part, which is if you just say if you just do the build env dev, then what happens is by default it expects the board to be connected to the laptop or to the computer via USB, and it tries to flash via USB. If you use the OTA build target, then it'll instead try to find the device over there and then flash the device that way, so you can be disconnected from the device. That's pretty much all I wanted to show in the software.